You're probably not going to take the whole hour?
Nah, probably like 40 minutes.
I just tried to do my head for No, it's fine.
Like, that's why I'm in no rush.
Okay. Glad to see you're all still able to stand on your own 2 feet. Yes, naturally. We have Robert Rowley here to talk on teaching your WAF new tricks. What does WAF mean, Rob?
Web Application Firewall.
Web Application Firewall. You learn something new every day. So just some quick notes. After this talk, in the room next to the bar will be the ham tests, the amateur radio tests. So if you're signed up to take those tests, go stand outside of there after this talk. After this talk, we'll be closing this room so we could set up for this evening's dinner and party. So don't go anywhere for dinner. We have your dinner covered starting at 8. It'll be a casino night. So you do have time, however, to go to a tux rental place and look all spiffy for casino night.
Where's the closest one?
I have no idea where the closest one is
You're not
because
helping.
no, I own them, straight up.
I'm gonna tux.
I own everything.
You think it will fit?
With the both of us in it, we'll see about it. Okay. Anyways, so give a big warm round of applause for Robert, and I'll see you guys after.
Thank you. All right. Let's try this. All right. Thank you all for sticking around. My name is Robert Rowley. I'm a security researcher for TrustWave SpiderLabs. I do not necessarily work with web application firewalls with my job right now, but my previous work, I actually worked a lot with web application firewalls, which is what most of this research is based on. So I'll go into that, but going ahead and getting started, foremost is a disclaimer. Seriously, I'm not responsible for any of you going back to your workplace and or home and running any of these scripts that I give you. The scripts here are kind of examples about what you can do. They're very useful, however, they're very limited, and they will also probably cause a denial of service on your own host, which I actually did myself on my own VPS, and I had to restart it and get it back from scratch. If any of you do have these problems, go ahead and harass me on Twitter. My Twitter handle is IamLay. So the agenda for this talk is a pretty simple introduction to basics on writing rules for mod security, which is what I'm going to focus on. Coincidentally, that is a TrustWave SpiderLabs product, but I've used it for years and years. Then there's a quick Lua introduction on how to write scripts using Lua. Basics of it's an object-oriented scripting language. It's very easy to show you, and I can pretty much go over it within 5 minutes. Then how it plays into using how it plays into mod security, what you can do with it, and then some more cool shit with basically utilizing mod security and Lua to turn your entire web interface into a kind of a counterintelligence tool, utilizing RFI hunting, malicious request, intelligence gathering, looking over data over large spans of time based on large attack surfaces, and more recently there's what I call the WordPress incident. Does anybody here have a WordPress hosted website or a site running WordPress? This is not applicable to any of you. Is anybody here familiar with that WordPress incident, which I might be talking about? The little quote-unquote denial of service where a bunch of WordPress sites went down? I got some data on that, coincidentally, because I used mod security in Lua. So it basically shows you how to utilize mod security in Lua to be a better researcher, as opposed to just a fucking utility that you use for PCI compliance or some security checklist. So why me? Foremost is my job right now is vulnerability assessment, but previous to this, I worked for a very large web hosting company, one of the top 10, and they hosted about 1 million plus websites. I was the only employee at that hosting company that was writing mod security rule sets, and I was writing custom scripts using this mod security rule set. So I have a specific experience writing mod security scripts and mod security rule sets for very large environments and crossing this over to this large environments. That's why, frankly, I should be able to say, I think I'm qualified to talk about this subject. Does anybody have better experience than me? Good. So the quick intro is the basic idea of the mod security is a lot of people use it to just write a rule. They either block or accept the request. Maybe they log it, and they repeat that. That's all they ever do. And I'm going to show you how to do this and how these basic rules work. But this isn't exactly what I enjoyed doing where I used to work, and I really took it to the next level. It's a level that, frankly, me as a researcher now, I don't see a lot of people doing this from an outside scope. I try to ask them for this data, and they don't actually provide it, and I was quite surprised. I'm like, this isn't hard to provide. I don't know why you're not doing it. It's good to note that mod security now runs, primarily, it always ran on Apache. It was an Apache module. It was easy to load. It ran very quickly, very well. Now it's in beta. It's actually running on IIS servers as well as Nginx. So most people actually don't have a good excuse as to why they're not running mod security. It's a good layer of defense for any web server that you're running. Unless you're running not Apache, not IIS, and not Nginx, which for my knowledge that leaves like Tomcat and some other bullshit, which you shouldn't run those in the first place. So back to the quick introduction. ModSec variables, basically it looks at various variables based on a HTTP request. And you can basically set a rule to accept or deny it. So you can look at things like args, which is these are the HTTP arguments, like get and post requests are variables. The names, type, and environment variables, files names. But more common ones are like the query string, the remote address, which is the IP address of the remote host. Request body, you can look at the cookies, you can look at the headers, you can even look at the request URA. The ones that I have bolded here are the most common ones that I ever write a rule on. But there's a lot of very useful things here. You can look at the timestamp of the request, which you can do time-based blocking on. There's a lot more than that list, but to show you a quick example of a basic mod security rule, who here is familiar with a PHP hash collision denial of service? Anybody? Just this guy, Sam, who's already seen my talk, and he's acting like it's nothing special. There's more at the end, don't worry. I've added. But this denial of service basically utilizes PHP, basically the way that PHP would gather and collect and create a hash variable for get and post requests as well as cookie values. If you told PHP to create that variable in the most inefficient manner possible, which you could do, which is called, this is where the collision part takes place, PHP would basically cause a CPU churn. So a single request would cause PHP to cause a slight CPU churn. Turns out you can make hundreds of requests within a second, which was faster than the CPU churn would be basically faster than the length of the CPU churn, which would create an indefinite denial of service environment. And this only occurred because you were creating thousands upon thousands of get or post or cookie values, basically like variables that were sent to PHP processor. And this only existed there, so this is a pretty easy rule to block, and it's a sec rule. And this ampersand here says number of args. And you do a comparison, which is the greater than 100, and the argument is to deny. So I say, basically, if the number of arguments here are more than 100, I want you to deny that. And in a very large hosting provider scenario, it's interesting because, I should say, in the individual hosting provider instance, you basically adjust this rule to be exactly what you need it to be, which for most sites, more than 100 get post arguments is probably excessive. Anybody here have a site that actually needs more than 100 get post arguments? I didn't think so. I think you scratched your neck, and I'm going to say you did, because there was one person on the network that I used to work for that actually had more than 100. And curiously enough, I had to bump it up on the entire network, because that's basically how our rule set application worked, was to over 1,000 different get post requests or get post variables. And frankly, it's one of those unfortunately systems where, well, I couldn't really look into this very in depth enough. I couldn't say that like these are the types of things that are acceptable and not. I'm just going to blindly accept or deny based on a vague overlook at this rule set. I'm going to just count the numbers. I'm going to say, yeah, over 1,000, whatever, deny. This ended up working out in the end, but it was kind of sad in my rule because I was like, really over 100 seems excessive. But this is the basic rule. So sec rule, number of arguments, we'll say, and then you do a comparison, and then you tell it to accept or deny the request. That's a very basic rule. So I'm going to show you now how to add some scripts. Who here can tell me which one of these requests does not look like the others? A, B, or C, going down the list?
B.
Oh my God, you guys are awake still. You're not drinking enough. You win. I think that was Tacitus. Obviously, B here has something very interesting. In the HTTP, like basically Apache server logs, you're going to look at the requests, and it's actually going to log the browser. It's the browser identification string that's supplied by the user, so it can be anything you want. So it logged the browser identification string. The first one is Mozilla for Windows NT Box. The second one is a PHP eval script, which is not a valid, no browsers actually use that. And the third one is a Mozilla, it's a Baidu spider. Obviously, you can see something's weird with the second one, so something's going on. Let's go ahead and look at this into a little bit more. We can say that request most likely, if somebody says, yeah, my browser is some arbitrary PHP code, something's weird. So we're just going to deny that. So setting up a rule here, sec rule, we can look at the request header, specifically the user agent, which is part of the request header. And if it matches the string here, PHP, we tell it to deny. This is supposed to be on one line, but it kind of ran out of space. So we tell it to deny, and this will block requests like this one. Basically, somebody making a GET request. And in this example, we're doing proc self-environment. This is actually a real-life example of a type of attack that isn't very popular or isn't very talked about very much. But this is a local file inclusion attack. When you have an LFI incident on a PHP ran website, and the PHP site will do a local file inclusion, you can tell it to include either the Apache access logs, or in Debian, Ubuntu, and other Linux systems, you can tell it to include the specific special file in the proc file system called proc self-environ. This is the null byte to tell it to stop there, but it will actually include this file, which will include this information, which is the browser string. And it will happily open that file, start executing it as if it got input from a PHP file. So it'll start printing out some bullshit because you said, oh, this is some bullshit, and then it'll encounter what looks like PHP code, and it just starts executing PHP. This is a local file inclusion to execution attack. I saw a lot of this, and it's kind of like a Hail Mary attack based on the attacker's, the amount that I saw. It's like, well, if it works, it works. If not, we don't care. And I just basically did a basic attack method. So we take this basic attack and this basic rule to block it, and we're going to add something more. We're going to say exec a script. So execute this script called Dirty Firewaller, and it's written in Lua. So a little bit of Lua intro is the fact that Lua is an object-oriented sort of scripting language. It's compiled as bytecode once you reload mod security or once you restart Apache. During Apache restart, it'll load all these Lua scripts as bytecode and runs very efficiently. It's super light, it's super easy to learn, so I highly recommend somebody learn it. It's available in other tools such as Nmap, Wireshark, and anybody here play World of Warcraft? Good, you're the only one, and really you should learn some more security stuff and stop playing games. But if you have some Lua experience, you got to step up on everybody else. So my example here is a Dirty Firewaller is what I like to call it. Again, I highly don't recommend you actually run this, but it's a good example of how a Lua script is written. So you have the main function, a lot like C programs. So you create a main block of code or main function. The next step is by setting, here's how you set a local variable. You say local bad IP is a variable name is equal to m.getVar remote address. m.getVar tells the Lua script to request back to the mod security instance and say, hey, I want to get this variable name from the mod security instance. And this is the same variable name, a remote adder, that we use during our rule writing session. So now it's basically the server's remote address, the person that made the request is assigned to bad_IP. The next thing we do is an os.execute, which again, this is clearly why you should not run this code, is you're doing a direct OS execute. This executes the following command on the system, writing an IP tables rule to basically assign a drop to any this specific bad IP address. So I don't really want to give you guys a really, really bad code. So here's another example. Instead of doing an OS execute to write to an IP tables rule, we'll just do we'll add that malicious IP address as a deny request into the site's htaccess file. So doing file IO is very easy as well. You create a file handler variable doing io.open. This says, open this file, the path to your htaccess file. The A+ is make sure it's append. All this is actually available in the Lua basically Lua documentation. Super easy to read, and basically you tell the file handle, you give it the option or the method to write, and you write the contents deny from, and then the bad IP address, and then you close your file handle, and you're done. This will, instead of creating an IP tables rule set, it will basically append a deny from IP address to your site's htaccess file, which is way safer because sometimes when you're testing this shit, you don't want to block yourself from the entire server using IP tables. You just want to block yourself from the site so you can still SSH in and remove yourself from the htaccess file. Or use whitelists, which is what everybody says to do. That's a really basic example. And what's funny is is here's another way. Actually, I should say here's another way to do this. You don't have to use exec. You can also use a special argument here called @inspect_file. So when you're writing a sec rule, you use the file's temp names. And what file's temp names is basically it's all the temporary file names that are created when a file is uploaded to a website. And you use @inspect_file, and then you give it the argument of the Lua script you want to run. What @inspect_file does is it runs that Lua script with all the arguments of the variable that you gave it. So that it will actually run this file inspector.lua, and if it says yes or no, it will deny. But all the arguments to file inspector.lua are the file temp names. So in this case, what I'm going to do is I'm going to scan every file that's uploaded to a website, and I'm going to tell it yes or no based on code that I've written, as opposed to based on a rule. Because these mod security rules, you can't really dig into file contents. So here's an example of file inspector.lua. So here with the main function, I'm actually giving it an argument, which is called file name. This is files.temp names. Each and every file.temp name is passed through this script as an argument. So it's ran through each file that's uploaded via website. Again, it's opening a file handle. So its file name is the temp directory file. And then it reads through each line of that file using this while loop. And if the string.match, so basically if the string that is string.match on that line that was read is equal to this quote unquote malicious in all capitals, which again, this script will not actually work unless you don't want people to upload shit that says malicious in all caps. So again, this script won't work, but the basic idea is here. So if it matches your known malicious content, then return 1. When it returns 1, that tells mod security as the mod security firewall to say deny. If it returns nothing or returns 0, then it says this rule is not valid. Like don't execute the action of this rule. In this case, would be deny. You can actually do this in the exact inverse, saying that only file temp names that include this quote unquote like a file with this line on it, basically like an image, like a known header for an image type, then only will you accept them. I don't have that example, but when I submitted this talk, because I work at TrustWave now and I have the close resources of other team members who actually work on mod security, and they frankly know more than I do because they wrote majority of the stuff from scratch. It was specifically Ryan Barnett read it and said, hey, by the way, we already have this implemented. It was been implemented since like 2.4. So it's kind of funny when I'm like, oh, here's a good example. But it turns out these things are actually really implemented in mod security. So if you actually want to do something like this, well, go read this. Basically, go search the SpiderLabs blog. Go read the code that's available here in this GitHub URL. And this is how you can implement ClamAV to scan every file that's uploaded to your website to know if it's a malicious file or not. All using mod security. And it's basically all pre-written code, so you actually don't have to write code yourself, but you can be like a cool guy saying, I'm running mod security with custom Lua scripting. There'll be more links at the end, by the way, if you don't catch it. You got it? All right. So I'll show you matching with script. So before I was just basically doing basic sec rule arguments, basically do matches and execute code based on that. Now I'm going to do a sec rule script where we're not doing any matching in the mod security configuration file. We're just going to run a script. And based on the output of the script, if it returns 1 or 0, we're going to accept or deny that request. So this request is a simple check blacklist. The check blacklist, what it will do is it will go through and it will look at the remote address. And if the remote address exists in this blacklist.txt file, which it goes through each line in the blacklist.txt file, if it exists, if the string match on the IP address on the line, then return 1. That which means, guess what? If this matched, then I'm going to execute the deny, basically the command that I told mod security to run, which is deny. And to make this a little bit better, there's a new command with mod security. Well, not really new, but something I'll introduce here is the chain command, which is you can basically chain 2 sec rules together. So 2 rules in the mod security. You could say, first rule is if the request URI is admin, so if something related to your admin interface here, if it includes the text admin anywhere, I'm going to deny it, but I'm also going to chain it to the next rule. So this next rule also has to pass. So the sec rule script of check blacklist has to also pass. This is a good way to The inverse of this, again, is to do it with a whitelist, where you would look through the remote address, and only if that remote address is included in your blacklist.txt, it's denied here, but do the opposite of whitelist.txt, and then return 1 to accept, otherwise deny. Once again, when I sent this off to Ryan Barnett, and I talked to him about it, he said, oh, by the way, we already have that included in Mod Security Core. So a lot of the stuff that I was trying to show you guys here, it's already done. Don't worry, it gets cooler. I hope that I've shown you some basic examples already. But you can do that exactly that using the @IP match from file rule, basic comparison. So you could do the sec rule of admin request, deny it if change to the next rule, which is if that IP match from file is in the blacklist.txt, it just denies that request outright. So Ryan Barnett basically is caught everything up to what we've done so far, but I'm going to show you guys something a little bit more. I hope I have enough time. I'm going to look at my clock. I got lots of time. So now I'm going to do counterintelligence. I'm going to take a drink real quick. Hope you guys have understood everything so far. Anybody at a miss? Nope. Everybody already knows more than I know? No? You don't count. You play WoW. So a lot of this is what I did at DreamHost, and a lot of what I did was applying mod security rules to do my normal day-to-day actions, making them way easier. Here's a script I call RFI Hunting. Remote file inclusion shell hunting. So I've seen a lot of blog posts about a lot of people that want to talk about web AppSec, and a lot of them like to post I found all these evil malicious shells because I grepped my HTTP access logs for something that looked like a shell, like an HTTP call or things like this. In this example, it's pretty easy to pull this from your HTTP access logs. The get is your thumb.php, which would be some retarded thumbnail program that you have, and the argument is the source is this site.com shell.txt. That's super easy to pull from your logs afterwards. It's mundane, it's stupid, you're going to get the simplest ones, and you're actually going to spend a lot more time than literally grepping the file and wgetting these shells than you ever need to. And it absolutely is useless if they just change their attack to a post request, because this is what your Apache logs would probably look like with a post request. Just a post.thumb, or a post.thumb.php. You have no idea what's going on here. You don't know if it's malicious. You're just kind of guessing at it. You think that might be where the point of attack is, but you don't know, because it's a post request, and Apache doesn't log post data. Intentionally, it doesn't log post data. It's a problem. So I wrote a mod security script, because mod security has access to all of that data, and more. It has access to absolutely all of the HTTP headers, which includes cookie information, all the post request data. So in this example, going through it, again, it's the main function. You assign 3 variables using m.getVar. The third one, the local args, m.getVars, is very important because that basically grabs an array of data. And then you have to use a for loop to iterate through the value of args, which is the arguments, basically the post data that was sent. And if that data that was sent matches the value, basically the args j matches value of HTTP. So if it has HTTP somewhere in it, that's what we want to look at. Then what you do is you actually open up a log file. Here, this is specifically supposed to be a log file. Temp backdoor is just a generic place to put it. You append to that log file, and you write to that log file information such as IP address. The dash 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 is just some bullshit in case arguments have new lines. You write the IP address, the URL that was requested, which is all set right there. You write the argument that matched HTTP, and the name of the argument that matched HTTP, and then the value of the argument that matched HTTP. You either close your log file here, and then you do os.execute. Using wget, these commands basically open up a new file based on which include the entire the request URI length, which is domain path. And then you dump it to temp RFI files, the value of this. So basically it'll go in, and when it sees an RFI attempt, it sucks down that RFI file, saves it to a unique location, and then moves on. In fact, in this specific one, it actually doesn't say accept or deny, so whatever your default rule is, it will accept or deny. You can accept it. You can say, I don't care that you tried an HTTP thing, but if it looks like an RFI attempt, I'm going to download that, and I'm going to send a non-obstructive response. And now what you have is an RFI folder that's full of potentially remote file included shells. When I first wrote this code, I honestly didn't think it would work that well. And within a month of me writing it and just kind of running it on my test server, turns out it fucking works. And I have examples of remote file, basically PHP-based shells that people were trying to inject on my sites. None of these were successful. These were just dumped into my RFI shell location. This one specifically is kind of funny. It's the Sembon crew. I don't know who they are. Anybody here from the Sembon crew? If you know who they are, it's you. I'm going to find you. I know where you work. But what's interesting too is that this is the RFI bot. Explicitly stated it's an RFI bot. And obviously, like, I pulled it based on my RFI loggers program. It has a version number. It has error reporting 0 or 1. It has a mode. And there's comments. There's very detailed information about the various attacks that they try to use and basically the stuff they go. And if you guys want a copy of this, I can give you copies of the remote shells. I really don't care. I mean, I pulled them all down. If you guys want to run, this is not really a honeypot. I call this a wasp nest. Basically, like, I'm not trying to just suck you in. Like, you attacked me. I'm going to fuck with you now. I'm going to go and find out all the information that you tried to inject on my site. I'm going to attack back now. Not really attack back, but I'm going to know everything you know that you attempted to do. I know everything about their RFI attempt, as well as their backdoors. They have no secrets that they've kept from me. And this is why I'm running this on a basic WAF. And this is why this is basic counterintelligence, and this is why a WAF is way more powerful than most people are actually applying it to be. Here's another one. This one is using like HTML. It's got this weird title in it. I don't even know. I just wanted to make fun of these guys because it just seemed like this was like write your own RFI bot shell. I'm like, I don't even know what's going on, but like it's obviously, it seemed to me some guy is like 15 or 16 trying to write an RFI inclusion shell. And it works. I mean, it didn't work on my site, but I obviously snarfed their data, and now they have no concept of the fact that I snarfed their data because they think their RFI shell worked, because their request initiated a request from my server to pull that data down. They think it worked. I just pulled their RFI shell. It doesn't exist on my site anywhere, but now I've got a copy of it, so I can do counterintelligence. A lot of what I did at my previous work environment was basically detecting these on post-compromised environments. So if a site was compromised already, what I would do is when the customer would notify us, they'd be like, I don't know, my site's compromised, or I don't know what's going on. I would be the one that would go out there and scan and identify all of the backdoor shells on their site and disable them and give the customer basically a simple report saying, here are all the compromised shells that I found on your server. Even more so than that is I was able to utilize mod security to flag when attempts were made to compromise the site to initiate a scan for known malicious, basically remote file inclusion shells, basically PHP shells, and scan for those and pull them off the site and notify a customer that didn't even notify the host. The customer didn't even know they were compromised. It's just the host sent out a notification, hey, by the way, we noticed you were compromised, and we cleaned everything up already, but here's some recommended actions for you to take from here on out. And that made things just absolutely like crazy for that host. Again, previous work. So here's a good example of what I call better than a blacklist. A blacklist just accepts and denies based on malicious requests. And really, I want to do more than that. So an example here is a known malicious request comes into the web server. The WAF script is ran, and it sees this as the known malicious request. So what it does is it captures the request, doesn't send a response. It'll send back a deny. It doesn't allow the web server to process it because it knows it's malicious. And then it logs the IP address. And this is key. So it logs the IP address so that later, an unknown malicious request, just a generic request coming into the web server, will hit a different WAF script that if it's an unknown host, just sends it an unobstructed response. We're going to send you a normal response. We're not going to worry about it. But if this is the known malicious host that has previously hit us with a known malicious request, we're going to say that this host is malicious, and anything else they send us is probably malicious as well. And so we'll capture the request. We'll not allow it to actually be processed on the server. We're going to log every bit of data about that request as possible. We're going to then later process those logs and look for new attack types that these attackers are using. This is putting it together. These are the basic examples of mod security rules that will work. These are two separate rules. They're not chained together, but these are two separate independent rules. The first one is, as I showed you earlier, an example, the request headers user agent looking like a PHP script. We're going to deny it and then execute the blacklist IP.lua script. The second rule will use IP match from file and then look through blacklist.txt. And if that IP address exists in the blacklist.txt file, deny it, but send them a status 200, which says everything was okay, you're just not getting any data back. And execute this uber logger. The uber logger is like this script that I wrote that will log every single bit of data about that request. And I'm going to show you these scripts right now. So blacklist IP Lua, basic example is, again, function main. You pull the local IP address using m.getbar. You open up a blacklist.txt file. You write the IP address to the text file. You close the file. We're done. Then uber logger, a bit more lines. These first 5 lines basically are assigning basically local variables, IP address, URL, arguments, various arguments, which is an array. The headers, which are also an array. The request headers are an array. And log string, which is blank initially. We just basically append to log string the values of the various headers that they were used. This will collect all the cookie data, all the post request data, things like that. And yeah, args will absolutely compress all the post data using the argument name and value. You dump all that on a single line to this uberlog file and locate it in temp. You can locate it somewhere else, but it's very dangerous actually, because post variables can get really big really quick. And there is a denial of service in this script here, which is why I do not recommend running it. I ran it, it crashed my server. You can cause it to like continuously iterate over itself and always pull its own data. But in any case, the basic example writes to uberlog and the IP address, the URL, and then the log string, which is the header data and the argument data. And then it closes the file and we're done. This is the data that you'll get back. This was me running an nmap Lua script, basically a various nmap like HTTP requests with various arguments against it, cross-site scripting attempts, blah, blah, blah. The log was much longer, but you can see a basic example here is one, is the first request is this obvious cross-site scripting attempt, which was blocked. And then another one is this PHP CGI vulnerability here, which would have attempted to execute some various PHP code on the server. So it requires a longer string than that, but it would test if that's effective or vulnerable to that exact attack. And this is basically what those rules look like. You can notice here, this is a lot more data than a basic HTTP or Apache request, or HTTP Apache log file. The request headers are there, and you can get the user agent, you can get the fact that it's nmap scripting engine, the request headers, connection closed, the host IP, the various arguments that were used via post request or get request in this sense. So you can use these scripts to, you can use these scripts to capture only malicious requests. You can log far more data. Like I've been mentioning, it's information like the request headers, the post variables, cookie data, the file uploaded data. You can get GUI IP information, do automatic response. If you say that I'm not certain about this request, but they're from China, so fuck that. Our customers aren't from China. We're just going to deny it now. You can look live data on the attacks, and you can also make pretty graphs. I mentioned pretty graphs, not like pretty as in beautiful, but pretty as like, they're pretty okay. So let me show you some of those graphs. This is actual data that I pulled. And this data is purple and an orange line to most people looking at it. The purple line is an E107 CMS code execution vulnerability, a very specific vulnerability against E107. The gold line is a very specific SQL injection vulnerability against Zencart. And what's interesting about these is this is live data, and this is about 10,000, maybe 15,000. This bottom line here is 15,000. It doesn't break that line really very much. And that's the base data. This is what I kind of called background data on the internet. Like both of these vulnerabilities at the time of this data being collected had been 2 to 3 years old. And you can see that this is why I call it background data, because let me introduce to you a new vulnerability. This is all collected in 2001, 2002, when this new vulnerability against WordPress Tim Thumb had been released. And that's what that vulnerability looks like. It was released just before the start of this graph, like about a week beforehand. And you can see something interesting is that there was this little spike right here. This is about a couple weeks in, and then this massive spike, and then it dropped down to almost the level of background noise. Basically, it was just something normal, but then it quadrupled whatever the background noise was at that time, quadrupled or more, the various attacks per day that we saw. This was a specific attack against Tim Thumb. Who here remembers this? This is about end of 2011. Only you, Sam, because you've seen this talk before. I know you saw it before. Don't shake your head. I was there. I know, because I gave the talk. But what's interesting is the first spike happens around November, beginning of November. This second spike where it really picked up was about 2 months later. And I found this novel. It's interesting. It's very strange to see an initial spike and then a lull. Right here, there's a lull. It kind of hit this background noise level. And then it picked up and it remained very affluent, very, very strong attack. So I'm going to show you a little bit more data. I'm going to expand this out about 3 more months. And I'm going to add another vulnerability. So the green line is still the Tim Thumb-based attack. You can see this is the lull. And it spans out. And it still actually maintains this level where it's 4 times or more the basic noise. And you're probably wondering what this red line is. Who here's, I mentioned it earlier, the PHP CGI vulnerability. Anybody very familiar with this? If the correct, well, let me explain it real quick. When Apache is running PHP as a CGI module instead of basically running it as a mod PHP, it was vulnerable to an attack where the arguments sent, basically everything following a question mark, would be executed as if they were command line arguments. So you can do it flags. You can say, oh, by the way, don't execute the PHP code. Just give me the source code, which is for some reason a command line argument for PHP. So you can say PHP-S and then file name, and it just prints out the file contents as opposed to running cat the file name. So PHP gave the developers of PHP gave PHP these various command line arguments, which worked against them here when PHP as a CGI vulnerability came out. I should also add that other arguments included -T, which is test mode. It basically ran the scripts as many times as possible until it caused CPU utilization. So that's a denial of service environment. It also happily lets you say things like, oh, ignore the PHP configuration file. I'm going to override it with these values. So you can tell PHP to run, oh, by the way, ignore any configuration files. Oh, by the way, also, the next argument, just execute that blindly. So it was effectively remote code execution with PHP. Super easy. And what was interesting about this attack was where I was working, we were giving forewarn a notice about the vulnerability where about a month beforehand, they said, hey, we found this. You guys are vulnerable to it, by the way. And we're like, oh shit, thanks. And we wrote we wrote a mod security rule saying, don't allow anybody to send arbitrary, what looks like command line arguments to PHP. Just block that request. And by the way, log it, because I was very interested in logging things. So right down here, you guys probably can't see, there's about a week or a couple of weeks of lead time where it's just nothing. Something's reading logged here and there, and those are just people testing stuff and various false positives. Then suddenly, this giant spike happens. This first day of a giant spike was literally the day the CVE was dropped. That was the O day. The day that everybody knew about it, immediately everybody started attacking it. What's interesting is about a week or so later, everything stopped. And then about exactly 2 months later, everything started again. In fact, it was more forceful, or basically almost equally forceful as the first time, with this one day, and even got more so about a month, 3 months later. What's very interesting about the correlated data, I only have two data sample sets, but with Tim Thumb and with PHP CGI vulnerability, it was exactly a 2-month lead before shit, initially it was an immediate attack with PHP CGI here, as well as an immediate attack with WordPress Tim Thumb attacks here. Almost exactly 2 months later, shit picked up again and maintained. Exactly the same thing happened with PHP CGI, shit picked up again, and maintained out to what I have available with the data logs here. Any questions? No? DG is running. I got 10 minutes? 15. That was like a fucking ninja shit right there. It was like, 15! So before I go in with the WordPress incident, yeah? Same.
What the 2 months means?
I don't know. I just have data. That's kind of what I felt like. Exactly what I felt like. It felt like it was development. Both of you saw my talks before. No, I'm just kidding. Yeah, exactly. That's basically like what I feel is if that was development time for the attackers to A, develop their own method, their own module to initiate that exact same attack, and B, like send that module update to all their bots around the internet. So that's kind of what I felt like. I don't know. I have no data. That's just kind of what I feel. And I mean, I agree with both of you. Both of you I've seen at security conferences before. So with the three of us, we now have a consortium. We've conspired, and we all agree that's what happened. It's not fact, but we all agree. Like gravity or evolution. It's a theory. It's very solid, but it's a theory. But so any other questions before I go into my last little bit? Nope, good. So let me talk about this WordPress incident. This is kind of like talking about monitoring remote brute force attacks. There was a beginning of basically April 2013, just a few months ago. This was reported by several large common shared hosting providers. And they said, there is a WordPress brute force happening right now, and this is why your sites are down. It's very interesting to hear this because you rarely ever see something like this saying, this is why your site's down, brute force attack. And a very specific security reporter, I'm going to call him Mr. Brian K., he blogged about it, and he said this was a botnet recruiting run. And you know, he's very good. He's blogged about stuff I've done before, and he's very good at getting a lot of attention onto a very specific subject. I don't commend him against it, but I think it was a little bit off, but very good for him. Coincidentally, though, I had been monitoring WordPress login requests with full data using mod security logs for months. In fact, since August. Why was I logging? Because somebody complained on Twitter. I don't ever recommend anybody complain on Twitter for anything because this is the first time probably anything useful has ever happened to somebody complaining on Twitter. That person's name was Vis. This is all your fault. I like the fact that I woke you up from your Shodan jacking off. You saw him coming 30 seconds ago? So this guy at Vis said, hey, I see a bunch of requests in my WordPress login.php, and there are a bunch of post requests. I want to know what's going on. Anybody know what's going on? And Ryan Barnett actually hit him up. He's like, oh, I'll look into that on our honeypots. And me, I just quietly initiated a rule, mod security rule, that said, hey, Uberlogger, which I already had written since TourCon, I was like, hey, the request URI, if it looks like a WordPress login, just log everything about it. Because I never log into my WordPress websites. I just want to log everything about those. Guess what the data I got? There's a bunch of data. They all look like very common data. There was no, I was kind of hoping for like a remote code execution, like a cross-site scripting type attack. No, these were legitimately brute force attempts. They were doing things like one admins. The password being webmaster. Always the login user was admin. And like, what was interesting too is like, password being 11111, and password being Naruto, which really made me feel like the people trying this brute force attempt were 16 years old. Maybe it's just my age, but I feel like these people were kids. It was absolutely the lamest brute force attempt ever. These are some of these other examples. And after this WordPress incident where these shared hosting providers were saying, oh, shit's going down. This is the biggest brute force attempt in the like history we've ever seen. Really what I felt like was, wow, some kids got a lot of bots. That's all it was. During the entire time that this stuff was being logged, I logged the same passwords over and over again. They were the dumbest passwords ever. And included here also Pokemon. What was interesting was there was one thing that was smart. It was site name. So site name is actually like your URL. So like yourdomain.com 123. They just attempted yourdomain.com, which was actually smart of them, I felt. But absolutely, in the end, I correlated all the data that I'd gathered with what various other people had published on these various attacks, and it completely correlated. Like all the attacks I was seeing was the attacks that they were seeing. And I was surprised that nobody actually reported that this was the stupidest brute force ever. Every Pokemon and Naruto and anime website out there got compromised. Every website that mattered didn't. Unless seriously your corporate website's password was Pokemon, which like just stop doing IT. Stop it. So again, like if I haven't made it clear enough, it was brute force. Yes, it was a very heavy influence, like a lot of request brute force, but it was super lame. And anybody who actually got compromised related to this was dumb. So, or didn't matter. Like, it's fine if you had a Pokemon fan site and it got compromised, that's fine. There's no problem there. Like, that site didn't matter. Sure, you got compromised, whatever. Move on with your life. Get a better hobby.
Serves them right.
Yeah. But it got press because sites were going down. And really, this was actually, to me, I felt like this is a failure of WordPress. Like, excessive requests to authenticate were a problem. So I kind of actually poked into the WordPress authentication methods, and I found a lot about them. But I ended up writing a WordPress blog post about this on the SpiderLabs blog, which I recommend you go to and check it out because it's kind of cool how I wrote that. But also, WordPress is completely a buzzword for security incidents. Like, you have security incident and you add WordPress, and now you got like 10 times more viewers because it's just how it works. Because everybody gets a minor hard-on or a little chubby about WordPress security. And pretty much that's the end of my talk. So here's a bibliography. So these are various links. The modsecurity.org website and lua.org websites are great resources to just pull in data about how to write your own mod security rules and how to write your own Lua rule sets. The SpiderLabs blog variously gets either posted by myself or Ryan Barnett or some of the other people on the mod security team. I'm not on that team, but the mod security team and myself, I wrote some stuff about various attacks, and they write some phenomenal rule sets on the basically SpiderLabs blog, and including a specific rule how to block that WordPress attack, brute force attack. The SpiderLab GitHub is there, and if you seriously want my code, it's over here in GitHub/Rowley. And I don't recommend you run it, but you can look it over if you want to really pick it apart and tell me I was stupid for running something in some way. It's fine. And if you guys really hated my talk, go pitchfork me on Twitter. There's my handle again. I'm going to accept it. Come on. But any other questions or such? Oh, shit. Let me go back to that. Any questions? Who wants to buy me a beer? Who wants to buy themselves a beer? Awesome. I got at least 2 people that owe me beers now. Not Sam Adams. I'm done. Yes, question?
Talk at DEF CON last year?
No, I did not. I gave a juice jacking talk at Sky Talks, which is about with cell phone security.
I've seen part of this somewhere.
I gave this talk at ThoughtCon. Before that, I gave it at Baythreat, and I gave it at TourCon. But I've added new stuff since. Sorry, so it was at TourCon, but I added all the WordPress stuff here. So you guys got new stuff. Thank you. Thank you. All right, I hope I finished early enough for everybody to get some drinks and some dinner. Drinks, 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 drinks. Oh my God, Datagram's not here yet. I fucked it up.
So, like I said, if you're doing the amateur radio exam, go stand by the boardroom. We need everybody out of this room so that we could flip the room for our casino night. Also our dinner, both of which start at 8. Outside, if you go to the right, one of our vendors, ASG, is doing a raffle giveaway of some sort. So if you're interested in that, go talk to Guy out there. Great guy, great company. Give him your support. I'll see you guys at 8.
BE session.
I told him.
Where's Flea?